Alright, so we're going to be talking about solving absolute value inequalities in this video, and this is actually only going to be the first of, I don't know, like 2 or 3 videos of these, because there are a few special cases with inequalities as well that I want to dive into a little bit more depth with, okay? And in order to get us used to solving absolute value inequalities, I just want to take a look at these 2 examples real quick, and we'll just kind of talk it out, okay? So for example, we have the absolute value of x is less than 3. And I just want to think about some values that would actually make this true, okay? What if x was 2? The absolute value of 2 is 2. 2 is less than 3. That would work. So x could be 2. X could be 1. X could be 0. All of those would work. It could be 1.5. It could be 2.5. All of those values would work. So we could have values that are less than 3, okay? But that's actually not all. It can't just be x is less than 3, because say x was negative 10. If x is negative 10, the absolute value of negative 10 is 10, and 10 is not less than 3. So there has to be more to this. Well, what if x was negative 2, or negative 1, or 0, or negative 1.5, or negative 2.3? All of those would work. So we actually kind of have a boundary with this one, okay? X has to be less than 3, and x has to be greater than negative 3. So this is actually, with absolute value inequalities, this is a type of compound inequality we have here, okay? Now when we solved absolute value equations, we set up 2 equations once we isolated the absolute value. When we solve absolute value inequalities, once we isolate the absolute value, we set up multiple inequalities called a compound inequality. And this is one type of compound inequality, the and compound inequality. It needs to be this, and also it needs to be that. It needs to satisfy both conditions. So x has to be less than 3 and also greater than negative 3. And the easier way of writing that out is actually negative 3 is less than x, which is less than 3. So this would be the solution, okay, in inequality form, all right? Now, this is always going to be the case when we isolate the absolute value and it's less than or equal to. So whenever we isolate an absolute value inequality and the absolute value is isolated and we're less than or equal to, we're going to have an and compound inequality, and our value is going to be sandwiched in between 2 values just like this, okay? An example of such. So let's go over an example like this one, all right? So an example, let's say we had the absolute value of x plus 6 minus 2 is less than 2. Okay, now I can't say for certain what type of compound inequality is going to be at the beginning of the problem unless we already have the absolute value isolated. So I need to do that first. In order to isolate the absolute value, I need to move this minus 2 over. That's the only other thing on this side of the inequality that's not inside the absolute value. So I need to move this over. So I have to add 2 to each side, okay? And that's going to get me the absolute value of x plus 6 is less than 4, okay? So now I have my absolute value isolated. So I isolated my absolute value, and it's a less than, just like in this case. Well, think about what this absolute value can spit out. The absolute value can spit out a value of 3, or 1, or negative 2.8, or negative 1, or 0. It's going to be values in between negative 4 and 4. It's an and. So x plus 6 has to get me a value that's less than 4 and a value that's greater than negative 4. So these are 2 inequalities, okay? And take a look at what I did. The first one is a copy and paste job, okay? I have x plus 6, nothing changed there. I have less than, nothing changed there. I have 4, nothing changed there, okay? For my second one, I have x plus 6, nothing changed there. But it's now greater than. I changed an equality symbol. It's now greater than. And it was 4, now it's negative 4. I changed the sign. So for your second inequality, we change the inequality symbol and the sign of that numerical value, okay? And there's actually an easier way of setting this up as kind of one big compound inequality. I can say negative 4 is less than x plus 6, which is less than 4, okay? Notice all the criteria is still met. I still have x plus 6 is greater than negative 4, but less than 4. And now I can solve this inequality. And this may seem daunting, okay? But it's really no different than solving either of these ones individually. If I'm trying to solve for x, I have x plus 6, I need to get rid of that plus 6. I would subtract 6 from each side. So I'm subtracting 6 from each side. It's just that there's another side I got to subtract 6 from. That's the only difference in this case, okay? That's the only difference. So I'm subtracting 6 from all sides to balance this inequality out. So I'm going to have negative 10 is less than x, which is less than negative 2. So that is our solution written as an inequality. If we wanted to, we can graph this on a number line. Okay, so let's say I wanted to graph this on a number line, and I'm not like a stickler at all. I'm going to say this is negative 10. This is negative 2. I would graph this by using open circles on both because we're not or equal to, so I can't be negative 10, I can't be negative 2. The open circle here is showing that, and if I want to be in between negative 10 and positive 2, I'm shading the area in between. So this is how we can kind of show it on a number line, okay? So that is our and compound inequality. If it's an absolute value isolated, it's less than or equal to, it's gonna be an and in between two values just like this, okay? So let me go ahead and split this. But what if we had something like this? The absolute value of x is greater than 3. Well, think about some values that would make this true. It could be 4, right? The absolute value of 4 is 4. 4 is greater than 3. That's true. It could be 10. Absolute value of 10 is 10. 10 is greater than 3. It could be 15. It could be pi. So x can be greater than 3. But that's not it. What if x was like negative 10? The absolute value of negative 10 is 10, and 10 is greater than 3. What about negative 100? The absolute value of negative 100 is 100, and 100 is greater than 3. So there's a bunch of other values that we can have. And this is when we have the or compound inequality. X can be greater than 3, that would work, or x can be less than negative 3, okay? So this is a little bit different than the and. And means I need to satisfy both of these conditions. This needs to happen, and this needs to happen. Or is like, you can do whichever one you want. It could be this, or it could be that, all right? It doesn't matter. It can satisfy either of these conditions, okay? An example of such could be something like this, all right? So let's say I had an absolute value, let's say we had this inequality. Let's say negative 5 minus 3 times the absolute value of x plus 1 is less than negative 8. That's a negative 8. I know I'm sloppy. Sorry. Now, just like before, I need to isolate this absolute value. So anything that's on this side of the inequality that is not inside of absolute value, I want to get rid of. And we always like to get rid of addition and subtraction first if we can. And I can. I can get rid of this minus 5. I have minus 5. I can get rid of that or move it to the other side by adding 5 to each side. So I can add 5 to each side. So once I do that, negative 5 plus 5, that cancels. I'm going to have negative 3 times the absolute value of x plus 1 is less than negative 3. From there, I still have this negative 3, and that negative 3 is multiplying the absolute value. It's not inside, it's multiplying the absolute value. Well, to undo multiplication, I want to use this inverse operation of division. So I want to divide each side by negative 3. So once I do that, I'm going to have the absolute value of x plus 1 is less than 1. Or is it? Remember, when you multiply or divide by a negative number with inequalities, you need to switch the inequality symbol, okay? So this is actually the absolute value of x plus 1 is greater than 1. Be very careful with that, okay? Whenever you multiply or divide by a negative with inequalities, you need to switch the inequality symbol so it now becomes greater than 1, okay? And now I have my absolute value isolated, so I have to set up my compound inequality. And if it's ever a greater than or equal to, it becomes an or compound inequality. So I set them both up. I'm going to go ahead and set them up here, okay? So I'm going to have, well, the absolute value of x plus 1, or excuse me, what's inside the absolute value of x plus 1. X plus 1 can get me some number greater than 1, right? If the inside of this gets me 2, the absolute value of 2 is greater than 1, it works. If x plus 1 got me like 10, the absolute value of 10 is 10, 10 is greater than 1, it works. That's one possibility. Or the inside of x plus 1 could get me some value less than negative 1, okay? So the absolute value of x plus 1 could be like negative 50, because the absolute value of negative 50 is 50, and 50 is still greater than 1, okay? So notice what I did there. The first one, everything stayed the same. The second one, I switched the inequality symbol, I flipped it, and I changed the sign, okay? The exact same case as with the and, except with or, it could be this or that, all right? And we solved this the same way we solve any other inequality. All right, I have x plus 1. I want to move that plus 1 over, so I subtract 1 from each side. And it's going to be the exact same in all cases, okay? So I'm going to have x greater than 0. So that's a possibility. X can be any number greater than 0 to solve this. Or x can be less than negative 2. So x can be any value less than negative 2. So these would be my two answers, okay? And we can go ahead and graph this on a number line as well. With inequalities, we sometimes like to graph them on a number line, because with inequalities, there's actually normally an infinite number of solutions, but they have to meet certain constraints, okay? So I have negative 2 here. I'm going to say 0 is here. Once again, since these aren't or equal to, I'm using an open circle with each. X can be greater than 0, so all values greater than 0, so I'm just going to draw an arrow going in that particular direction. Or x can be less than negative 2, so I'm going to draw an arrow in that direction. So that could be your answer graphed on a number line. And that's solving absolute value inequalities. I'll probably do another video or two going into some more complex problems, and especially the special cases, because we are going to have special cases. All right.